Welcome back to Learning with us here at MPB. I am Ms. Killen. We are still in our Unit 6, Introduction to Quadratics, but now we are looking at 7B, completing the square to solve quadratic equations. I can solve a quadratic equation by completing the square when a equals 1 and when a is greater than 1. I'm looking at standards REI for A and B. So let's dive on in. First, let's remember something. We've got our standard form, A, B, and C. We need to remember and recall the steps that we used in our previous lessons when we were working these different type of quadratics. And we can always check our answers with Desmos or our calculator skills that we've learned. So we want to make sure that we have those. So let's look at this. Now let's see what happens when we take things out from under the square root symbol. So that should give us a hint of what we're doing. So the first thing, we're going to just work this one straight through. So let's go ahead and do this. So I am going to find the factors here of 59 that will subtract to give me 6. So let's see what we've got. When I put this into my calculator, do I have any factors that will subtract to give me a positive 6? I don't, you're right. So now I've got to figure out a different way to do this. Now we've learned multiple ways. So let's see what we can do here. All right, so let me go ahead and erase this so I can have all this space. So what I'm going to do is I'm going to move my C, because remember we have A, B, and C. So it gives me this, so I can put my new C, and it equals 59. So then what I'm going to do to find that new C, I'm going to take my B, divide it by 2, and then square. So I have 6 divided by 2, which is 3 squared, is going to be 9. Whatever I do to one side of my equation, I must do to the other. So then I'm going to rewrite as w squared plus 6w plus 9, and that is going to equal 68. Now, want to isolate those w's, so then I'm going to build my two binomials, which I'm going to have w and w. I am going to use the factors of 9 that add to give me a 6, obviously is those 3's. When I see something that is multiplied to itself, it is doubled. So then I am going to rewrite this as w plus 3 squared equals 68. Still need to get that w by itself. So what I'm going to do is I'm going to take the square root. Whatever I do to one side, I do to the other. So we're going to go back over here. So I have w plus 3 equals the square root of 68. Now, 68 is not a perfect square, so what I'm going to do is I'm going to factor some things out from under that radical sign. I'm going to pull out factors. Now remember, when I'm taking out from under the radical sign, I'm looking for those doubles. I can pull doubles out and then I have to leave the singles under. I'm circling those doubles, indicating that's what I'm pulling out, and then I'm putting a box around those singles so I can see what's staying under. So let's see what we've got. So when I have factors of 68, let's do that up here. I have 2 and 34. Factors of 34 are 2 and 17. Well, there's a double that I can take out from under my radical sign, but my 17 is going to stay all by itself. So that's what stays under. And remember, anytime that we have square root, it's always a what? A plus or a minus. So I have w plus 3 equals positive or negative, or plus or minus, 2 square roots of 17. Still have to get that w by itself, so I'm going to subtract 3 on both sides. So my answer here is w equals negative 3 plus or minus 2 square roots of 17. This is my answer. I had to factor some things out from under that radical sign. That's why it's easy for me to circle when I see doubles and then just put a box around the singles. Now, you may not have to do that, and that's okay. Sometimes I get all those numbers messed up, so that's why I do my circling and my boxing. Either way is perfectly fine as long as you can get the math done. That's A-okay for me. So let's look at the next one and see what we've got. It says, next, let's try when A is greater than 1. Remember what our standard form is. Reduce all, if possible, by a common factor, and then complete the square. So first, I've got to get that in my standard form. So I have 5x squared equals 60 minus 20x. I need to get it in ax squared plus bx plus c, so I'm going to move everything over. So that means I'm going to have 5x squared plus 20x plus 60 equals 0. Now, do I have anything that I could possibly do? Well, what if I divided all of these numbers by the greatest common factor? That is another way for me to get that greatest common factor out of the way. I can just divide it out. Okay, so when I divide something out, I'm left with what it was divided. So then anything divided into 0 is what? It's 0. So I've got 0. 5 divided by 5 is 1, so there's my x squared. 20 divided by 5 is 4x. 60 divided by 5 is going to be my 12. Now, this one was supposed to be negative. I don't want us to mess that up. Let me write it in a different color. That's supposed to be negative, because when we moved it over, it had to be negative. So that's where that came from. All right, so now I do not have factors, or do I have factors? Do I have factors of 12 that I can subtract to get a positive 4? Let's look. So I have 12, which is 1 and 12, 2 and 6, 3 and 4. Do I have a pair that I can subtract to get 4? Yes, I do. So I am writing my x and my x. This indicates that one's going to be positive and one's going to be negative. So then I've got what? Exactly right. Positive 6 minus 2 equals 0. All right, so then when I take these factors and equal them both to 0, x equals a negative 6, x equals a positive 2. So I write in numerical order. And there you go. So now we have yet another way to get those greatest common factors out of the way. I can just find it and divide it by all of my terms. Now, sometimes it's not going to work out like it did. Sometimes I'm not going to be able to be left with a 1 as my a. So yet this is another way for us to do. If your greatest common factor is what your a is, this will work. If it's not, it won't. So I have shown you yet another way for us to do this. Good job, good job. All right, so now let's look at this. It says you can factor out doubles, circle your doubles, and put a square on what's left. That stays under the radical, which we've done. Let's notice this type of equation. All right, here we go. So what do we got? First, I know that my a is more than 1. So I've got to find a greatest common factor. So everyone now pick up your calculator, and we're going to put those 3 numbers in how we learn to do this. We're hitting math, we're scrolling over to numbers, going down to 9, and we're going to put that twice because we have 3 numbers. So math over to number 9. I'm putting 3, comma, 48, close parentheses, comma, 33, close parentheses. I get a 3 as my greatest common factor. So I can do what I just learned and divide everything by a 3 and get that greatest common factor gone. When I do that, I'm left with x squared minus 16x minus 11 equals 0. All right, now my factors of 11 are never going to subtract and give me 16, ever, because it's just 1 and 11. So this is a good time for me to do that, completing the square. So for me to do that, I am going to move my C, remember, A, B. I'm going to move my C, and whatever I do to one side, I do to the other. So I have x squared minus 16x plus my new C equals 11. Now, how did we get our new C? Exactly right. We take our B, divide it by 2, and square it. So let's do that. Negative 16 divided by 2 squared gives me what? Exactly right, 64. I am adding 64 on both sides. So let's rewrite this. X squared minus 16 plus 64 equals 75. So now I need to build those binomials so I get x by itself. So building my binomials, I have x and x. This one tells me that both of my binomials will be the same as the first. So then I'm going to put that as x minus and x minus. I have to find the factors of 64 that will add to give me a negative 16, which is my 8. Anytime that I see that I have the same thing being multiplied, I can put it as x minus 8 squared equals 75. Now I need to isolate that variable. So to get that exponent gone, I'm going to take the square root of both sides, and I'm left with 8 minus x equals. Now, 75 is not a perfect square, so let's see if we can factor anything out. So what are my factors of 75? Well, I've got 1 and 75, obviously, but I've also got 5 and 15. Well, 5 is a prime number, but 15 is not. So I can pull out a 5 and leave a 3. So I have plus or minus 5 square roots of 3. Still got to get that x by itself, so I'm adding 8 to both sides. So my x equals 8 plus or minus 5 square roots of 3. Check my work, see what we did, check yours, and see if there's any questions. Looking how we got our new C, seeing how we factored that new C to get that x by itself, pulling out the factors from under the radical. Make sure that you are understanding these different steps and processes. All right, let's look. Okay, so let's look at more practice. So I have h of x equals 2x squared plus 24x plus 29. Now, we always need to remember our GCF, but when I look at these three numbers, I have a prime number. 29 is prime, so I cannot take a GCF. So let's just go ahead and move my old C out of the way so we can make room for a new C. So I'm subtracting 29 from both sides. So I have 2x squared plus 24x, making room for that new C, equals a negative 29. Now, on my left side of the equation, I can now take out a greatest common factor. 2 and 24 have what in common? You're right, it's 2. So I can take that 2 out, and I'm left with x squared plus 12x plus my new C equals a negative 29. Now I need to make that new C, and how do we learn to do that? I take b, divide it by 2, then square it. So I have 12 divided by 2, which is 6, and then I square that, and I get a 36. Now, you're probably thinking, okay, Ms. Killen, let's just add that 36 to the other side. We are going to add the 36 to the other side, but if you remember, we took out a greatest common factor. So when I put something on the other side, I've got to put that greatest common factor back in. So what I'm going to do is I'm going to take 36 and multiply it by the 2 before I can put it on the other side. 36 multiplied by 2 is what? Is right, it's 72. So I'm going to add 72 to both sides. All right? So now let's rewrite this. 2x squared plus 12x plus that new 36 plus, and then I get negative 29 plus 72, and I get a positive 43. Now, what I'm going to do before I can make those binomials, I've got to move that greatest common factor. So if I want to get it off of one side and to the other, I'm going to do opposite operation. Well, what is that 2 sitting out on the outside of that parentheses being done with? It's being multiplied. So for me to move it, I've got to what? You're right, I've got to divide. So let's go ahead and do that. I'm going to divide it here, and I'm going to divide it here. So I'm left with x squared plus 12x plus 36 equals, and that does not give me a whole number when I take 43 divided by 2. So I'm going to leave it as 43 divided by 2. So let's move up here to this other side so we can have some more room. So I have x squared plus 12x plus 36 equals 43 over 2. Now, we have always done this where we have to build the binomials and the x by itself. We're still doing that. But Ms. Killen, there's a fraction. That's okay. Fractions are part of life. We're still going to do the same operations with the fraction. Just watch and see what we do. Here we go. So I'm going to build my two binomials, and it's still equaling 43 divided by 2. I have my x and my x. This one tells me that both of them are positive. Factors of 36 that add to give me a 12 is a 6. I have the same thing being multiplied, so I can show it this way. All right. So now, still have to get that x isolated, so I'm going to take the square root. Now, when I take the square root of that fraction, if I can pull something out of the top or pull something out of the bottom, then I can do that as normal. When I take the square root of 43, that's a prime number. When I take the square root of 2, that's a prime number. So I'm going to leave them as the square root of that fraction. So I'm going to have x plus 6 equals plus or minus the square root of 43 over 2. Isolating that variable by subtraction. So my answer is x equals negative 6 plus or minus the square root of 43 over 2. Whew, Ms. Killen. It is an extra step, but that's okay because we want to make sure that we're understanding all the ways that our possible questions can be shown to us. So the more practice we do, the better we're going to get at this. So don't worry, we have this. Let's look at some more. All right, it's time for you to master. I have y equals x squared plus 10x plus 15, x squared plus 16x plus 17 equals 0, and t of x equals 2x squared plus 24x plus 17. You and your table partner, or just by yourself, work these problems, see what the math is, get your answers, and then come back to me and let's see what we got. All right, now that we worked these, let's see what Ms. Killen can do, and let's compare. Here we go. First thing I'm going to do is look at my problem and see what my numbers have. Do I have a GCF here? Well, no, Ms. Killen, you don't. So then I'm going to start working. So I know that I have 15 as my C. And do I have factors of 15 that will add to give me 10? I do not. So then what I'm going to do is I'm going to have x squared plus 10x plus 15 equals 0. I'm going to move my old 15 and rewrite x squared plus 10x plus a new c equals negative 15. To get my new c, I have b divided by 2 squared. 10 divided by 2 is 5. 5 squared is 25. I am adding 25 on both sides. So now let me go ahead and rewrite this. I've got x squared plus 10x plus 25 equals, and then I had negative 15 plus 25, and I'm getting a 10 right there. All right, so now let's build those binomials. I'm building those binomials by taking factors of 25 that add to give me a positive 10, and that's going to be a what? You're right, it's going to be 5. When I see I have the exact same thing, I can rewrite it. Need to isolate, so I'm going to take the square root. X plus 5 equals the square root of 10. Now, when we try to take the square root of 10, I do not get anything that I can factor out because I have 2 and a 5. That's it. So I'm going to leave it as the square root of 10, but I'm going to indicate it as plus or minus the square root of 10. Still got to get that x by itself, so I'm going to subtract 5 on both sides. My answer is negative 5 plus or minus the square root of 10. Check my math, check your math. See if we did the same thing. See if we got the same thing. All right, let's do the middle one now. I have x squared plus 16x plus 17 equals 0. So I know that I do not have a factor of 17 that will add to give me 16. So I am going to subtract my 17 on both sides and rewrite x squared plus 16x, making way from a new c, equals negative 17. To get my new c, I take b divided by 2, which is 8, and square it, which is going to be 64. So I'm adding 64 on both sides. So let's rewrite that, make it a little prettier. X squared plus 16x plus 64 equals, and I had a negative 17 plus 64, and I got 47. All right, so now I need to build those binomials. So in building those binomials, I get the factors of 64 that add to give me 8. Now, have y'all noticed the pattern yet? Have you noticed this pattern? When I build these binomials, like right here on this first problem, I took a 5, and that's what went to that binomial. When I take that b and divide it by 2, I get that 5. Then I square it and get the new c. But when I go back to the binomials, it's what I get when I divide. Every single time it will be what you get when you divide. So I'm going to have x plus 8 and x plus 8, because 8 and 8 is 16. So there's one step that we can maybe eliminate from you, knowing that every time I divide to get the new c, before I square it, that's what's going to go in my binomial. Just something that we should see in our patterns. So now let's rewrite this. And then I need to isolate that variable, so I'm taking the square root, and I have x plus 8 equals the square root of 47. Now, 47 is a prime number. I can't pull anything out, so I'm just going to have to leave it as plus or minus. Isolate by moving the 8, and my answer is x equals negative 8 plus or minus the square root of 47. Check your work, check my work, make sure that we did all of our signs properly, make sure that you see why I said before you square that new number, that's what goes into my binomials. So with that in mind, let's try this last one and see what we got. All right, I do not have a common difference in my 3 numbers, so I'm going to move my old c and make way for the new. Out with the old, in with the new. So here's my new one. All right, so let's get a different color because I'm getting tired of looking at the yellow. All right, so as always, I look on the left side and I have 2 and 24. I can take a greatest common factor out of those. I can take 2 and I can be left with x squared plus 12x, making way for that new c, equals negative 17. Get that new c by taking my b, dividing. So 12 divided by 2 gives me a 6. Let's just leave that there for later and square it and get a 36. Now, I have to put that addition on the other side. So what did we say earlier when we took out a greatest common factor, but then we had to put the c on the other side? We're having to multiply what we have for our new c to our greatest common factor. So 36 times 2 is what? 72. So let's rewrite this as 2x squared plus 12x plus 36 equals. Now, we have negative 17 plus 72. And what do we get when we do that in our calculator? Plus 72, I get 55. So let me put a positive 55. All right, So now I am going to move that greatest common factor. All right, so I'm going to rewrite this as x squared plus 12x plus 36 equals 55 over 2. All right, so let's see what we've got. I have to build those two binomials, so all right, so I have to have the factors of 36 that add, give me 12. Well, let's go back up here and what we learned. I'm going to use that 6, so I have x plus 6. X plus 6 I can rewrite as x plus 6 squared equals 55 over 2. All right, so I have to isolate that variable by doing my... Now, Miss Killen, I know 55 is not a perfect square, and I know 2 is not a perfect square. So what do? Well, let's see if we can pull anything out from 55. We'll just have to see. So I've got 55. Now, what are factors of 55? Well, 1 and 55, but then we have 5 and 11. Well, Ms. Killen, I can't pull anything out. So we're going to leave it as the square root of 55 over 2. So I'm going to rewrite it x plus 6 equals plus or minus the square root of 55 over 2. Subtract that 6, and I'm going to put my answer over here. So x equals negative 6 plus or minus the square root of 55 over 2. Check your work, check my work. Make sure that I did all the correct adding and subtracting. Make sure that my signs are correct, okay? You always want to make sure that you're double checking those signs, double checking those adding and subtracting, multiplying and dividing, all right? Things we don't want to forget. Quadratics can be factored many different ways, and we've seen those different ways that it could possibly be factored. Don't forget, always look for your GCF. Completing the square has multiple types, so we've seen many of those types. Always try to factor out from under the radical. Sometimes it'll work, sometimes it won't. You just have to try. And remember, you can always check your work with our technology tools. We are learning those Desmos and those calculator skills for a reason. I'm so glad that you came here to learn with us here at MPB. I am Miss Killen, and have a great day.